Hello, this is my Module 3. So my data is looking at students' honors enrollment status and includes math scores and socioeconomic status, with math being a continuous variable, SES being a categorical variable, and honors enrollment being the dichotomous outcome. SES is dummy coded in 3 levels using middle as the base. Dummy coding assumes that our codes are orthogonal, which works in this case because we have discrete categories, meaning that participants cannot belong to more than one category. So here we have 2 comparisons, low compared to middle and high compared to middle. So I started by running an ordinary least squares regression with math, SES, and the interaction effect. Normally, the B's represent our regression weights expressed as rise over run, or how much increase we expect in Y for every incremental increase in X, which is the case for math. But in the case of SES, it's important for us to remember that the intercept is represented by our base, which is middle SES, and the B's for low and high represent the incremental increase in Y we expect for every incremental increase as compared to the base. So we also have a significant interaction between high SES and math, such that the relationship between math and honors enrollment is different from middle and high SES. And this model explains about 35% of the variance in honors enrollment. But if we take a look at the distribution of our dependent variable, we see that we have a dichotomous variable, so it doesn't meet the Gauss-Markov assumptions, which makes our OLS model uninterpretable. So we would need to consider moving to a generalized linear model. And according to Press and Wilson's article, logistic regression would be preferable to discriminant analysis because we're dealing with non-normality here. But it's also important to consider that binomial logistic regression performs best when you have a more even distribution of zeros and ones, but that's not the case here. So we decided to use a Poisson distribution. So the generalized linear model allows us to deviate from Gaussian normal distributions, but it is still a fixed effects model, so we're still getting fixed coefficients. The estimates that we get are a little different because they're in log odds, so our B's are the probability of being a case over the probability of not being a case. They tell us how much each one of these variables bumps up the log odds. For example, for every single point increase in math score, the natural log of the odds of being enrolled in an honors program increases by about 0.09, holding all other variables constant. The interaction is not significant, but it describes whether or not the slopes for math and honors enrollment are statistically different for each level of SES. The log odds can be very difficult to interpret, therefore we exponentiate the log odds to get odds ratios. These odds ratio values indicate the bump or change you see in honors enrollment for every incremental change in each one of our scales. When we're looking at the confidence intervals of our odds ratios, we want to make sure one is not included because that would show that there's an equal probability of being enrolled versus not being enrolled. If we look at our confidence interval for math, it is significant because it does not include 1. So for every increment in math points, you get a bump in the odds ratio of 1.09, or the odds ratio increases by 9%. So logistic regression follows the same assumptions, but does not require a Gaussian normal distribution. It's important to keep in mind that these diagnostics can be misleading because, again, we're not working with a Gaussian normal distribution, which supports Friedman's point that the assumptions in a statistical model are hard to prove and disprove. In conclusion, although OLS and logistic regression produce fixed effects, logistic regression is more appropriate here because we have a dichotomous outcome, and as we've seen, you can get very different results. So while the OLS suggests that the intercept in high SES math and the interaction between high SES and math are significant predictors, the logistic regression reveals that it may only be our intercept and math that are significant. And that's my Module 3. Thank you.